Hello everyone, and welcome to another session in Python. Today we are going to look into what functions are. Yesterday we have covered very basic definition of function. We have seen about iterators, iterables, the control structures that we have in Python. Now we are going to look into what are the different ways in which we can define a function, we can use the function. For that I need my editor to be running, so let me bring it up. Okay. So this was the yesterday's program in which we have created a function using the def keyword. We have passed it a parameter, used that parameter inside the function, okay, and then returned something out. So we are aware of return, we are aware of a parameter, we are aware of the def keyword. We also know that any of the code block that you would be starting should be one tab indented inside the parent line, as well as it should start with a colon. If you want to end it, you will have to place a line which is not indented. Okay, so far so good. But let's write a function that would do something else now. I want a function that would be calculating the sum of two numbers. Very simple, right? So def space add. If I want to pass two numbers, I will have to accept two numbers. Correct? And let's see what the values are. So I would simply print x. Now there are ways to use print statement as well. We have seen one method in which we have formatted the string like this. But that is not specific to print. You could also use it apart from print. In print, you could pass multiple arguments. So I could say x, comma, the variable x. I could say print y, comma, variable y. Let's make it a little beautiful. So I would simply add a colon here and a colon here. Another way of doing the same thing is to write print x and then concatenate that with typecasted x. You cannot concatenate number and string directly here in Python. You'll have to concatenate the number first into string and then use a plus operand between these two so that that is properly concatenated. Okay, you could do the same thing for y. Okay, what's other way of doing it? We could write print, then the format operator. So I would say x colon %d, and %d would be filled in by x. I could just say x, and similarly for y. So we have already seen a lot of stuff that relates to this. To give a function call, you will have to call a function name along with the parentheses, of course, and you will have to pass the exactly same number of parameters as you are expecting inside the function. You cannot say that I need two parameters, but I'm going to call a function without any parameter list. That wouldn't work. So if I pass 4 and 5, I should be getting x colon 4, y colon 5 every time, right? So let's check it. It's x4, y5. All the results are exactly the same, even if we are written it in three different possible ways. Okay, so what I'll do is I want to return the addition of it. So calculate the result equals to x plus y. Very simple, right? And either you print the result or you return it out. So whenever you call this function like this and you print the result itself, this is a simple function. Okay, these are not fruitful functions. They are not returning anything. We cannot use the result somewhere. They are doing their own math. They're calculating it, printing it. So that's a very simple function. But when this print statement converts to a return statement, and we are getting the results out, we could say that this is a fruitful function and the result could be stored somewhere in the variable, and then I could do whatever I want with the variable outside the function. So these are fruitful functions. I told you that we could return multiple values from the function, right? So let's say I want to calculate not just add but also subtraction. I want to calculate add as well as subtraction. So how do I store it? Into two different variables. I want to return two different variables rather. So I would say result of add and result of subtract. So see that I am assigning the value from the function to two different variables now. And we know that simultaneous assignments can be done using tuples. So if that is a simultaneous assignment that is supposed to be happening, I should be returning a tuple from within the function. So I would say I'm not going to simply return one single variable, but rather than I would be returning two different operations, which is x plus y, okay, and x minus y. Makes sense? I'm returning two values. Actually, that is a tuple. If you look at this expression, it is actually a tuple which is defined in the parenthesis. So when you return two values, you will have to assign it to two values. Since in simultaneous assignments, left-hand side operands should be exactly matching the number of right-hand side operands. So when you do this and try to print the result of addition and the result of subtraction, let's see if it works. So that worked perfectly fine. Addition is 9 and subtraction is 4 minus 5, that calculates to minus 1. Okay, so we have seen how to return multiple values from the function. What are the ways the function would accept the parameters? Getting back to the same example of addition, okay, so in this example of addition, I'm going to make some changes. The changes are, if someone provides just one argument, the function should work. So what I'll do is, I would set up the right hand side arguments to default values. So now x accepts the argument and y it accepts the argument as well, but y would set itself as 0 if no argument is passed. This is how you get rid of the second parameter. And now the answer is going to be 4 because 4 has got nothing to add itself to. The default value is 0. If you change the default value to 10, then the answer that you would be getting would be 14 instead of just 4. So that's completely up to you, okay, how to deal with this. There is another way of using the variables now. If I specifically want to set up x and y, okay, if I specifically want to set that x should be equals to something, y should be equal to something else, in that case we could specify that in the parameter list as well. The use case would be if the function is accepting some user parameters, and user might be having a lot of parameters including first name, last name, phone numbers, a lot of default parameters like address, country, state, city, and so on, but you are not aware of the order of it. Okay, so order does matter because these are positional arguments, but you could also pass keyword arguments that would nullify the order form. So here I could say y equals to 8 and x equals to 6. So I could reverse the order, or I could give the elements in any order I want, but I need to make sure that the parameter name that I'm using exactly matches the parameters. How do I do it? In the IDE, any IDE that you would be using, you would be getting some autofill kind of thing. So we typed in y equals to 7. Now it gives me the parameter list. X is also there. So we would be adding X to the list as well. Okay. X equals to, let's say it is 3. So if we give it a shot, now it is going to calculate the addition. You see X is 3 and Y is 7. It doesn't matter which particular order you give these parameters in. This kind of parameter passing is called keyword parameter passing or keyword arguments passing. Okay, so these are not available with other languages. This is very specific to Python. What else can you do with a function? You can treat a function as a generator. Okay, let me tell you what a generator is. Generator is a function that generates a list, and you have already seen a function that would generate a list for you. Range, right? Print range 10 would generate you a list from 0 to 9. If you want to do the same thing, okay, of course your use cases might be different. You are returning maybe 10 different numbers, Fibonacci numbers, or 10 different factorials, or 10 different sum values, any list. Okay, it could be maybe names of students in a class, but you want to save some space and you don't want to return the complete list at once. So what do? We convert the function as a range function. So in my the new function that I'm going to write, let's say the function name is generate list, and here in this generate list I would be generating a list of maybe random strings. Okay, so I want some random strings to be generated. I don't know which string, just some random string. For that I would be requiring some help from the other functions. So let's see. So this generate list would be returning random string. And how many strings? Generating random n strings. And n would be received here. Okay, so let's do it. So I would say for every, not every, it's for every um, count in range n. You want to loop those many times, right? I want to send back those many strings. So for every number in that range n, or every count in that range n, so whatever you feel suitable, I would be um, generating a string. So join is a method that you could call on a string. Now there is a library called random. Currently don't worry about the libraries. I'm just giving you a hint, and we would be writing our own libraries later on. So random is not defined. Let me define it. Import random and string. Okay, so if you see the result on the left hand side, you would be getting some random strings. So that is my function's work. It would be generating a random strings. But currently it is printing it. I want it to be returned back. Okay, so if I want it to be returning, what I could do is one way of simply returning that stuff is to store that into a list. Okay, so what I could do is I could simply create an internal list. I would say my list is res list result list equals to some empty list. and we could rest list dot append a value, and this would be the value that I want to append. At last I could return the result list, then print it out. Very simple, right? But I don't want to return it once, because a list would be bulkier. If I need 100 or 1000 of different elements, that is going to be a huge and bulky list. I don't want that to happen. I want to save some memory. At the same time, I don't want to load the complete list into a for loop. Eventually, I want to loop over this list. I know that, but I want one element at a time. I want to convert that into an iterator. Okay, in order to do that, I wouldn't be requiring res list. I don't want to return anything from within the function. So what I'll do is, instead of appending that to the list that I was printing, I would do one thing. I will not store it anywhere. I would simply say yield. So yield is a keyword that helps you return multiple values from the function, okay, but one element at a time. So let's see how to use this one. Whenever you are yielding from the function, that is called a generator function. That is not called a fruitful or returning function. We could use it like this in a loop: for every string in, I would say, for every random string in this list, print the random string. Still we get the similar answer. Okay, but this time we have not generated a list. So what is happening when you give a call to generate a list? Let's give it a call directly. Generate a list 5. What do you return? Let's see. Print. So it says that it is a generator kind of object. That's why these functions are called generator functions. They do not give back the value directly. They would be giving back you a reference, and that would be a iterator reference to on which you should be able to iterate. Okay, so using a yield keyword, you would be generating or creating a generator function that would be generating multiple values on which you could loop. So far so good, but let's get back to that function again. My add function was supposed to be taking multiple values, right? We passed two values to it, it took it. We passed two values in different orders, it was okay with that. But now I want the add function to take in n number of values, which I don't care how many are there. The user would be able to send any number of values to it. So I say that, okay, I don't know the number of values that my function would be expecting. So simply star arg should work. Args, since starts multiple. You could write any name, but do not forget the star. Single star means positional arguments. So I could loop over these arguments. Let's see what the arguments are. Okay. And I'm giving a call to add and passing it few arguments. So it says if I print the arguments, it is actually contained in a curly, not curly, in parentheses. That means it is a tuple. So args is actually a tuple which is holding all the arguments that I've passed in the same order. So these are positional arguments. So how do I iterate over it? I would say for every argument in args, keep on adding. So we say res equals to arg, or res plus equals to arg, where res is 0 initially. Res is the result. At the last we return the value. Return res. Okay. So if you add all these numbers and print them, you would be getting answer 21. Okay, it's good. But if I want to add a user, okay, so if I want to add a user to the database, User would be having different attributes. Those attributes would be talking to the columns in the database where you want to store them. So we have passed something like this. Name equals to ABC. Siri equals to alpha. Country equals to gamma. Okay, so like this. I don't know how many arguments are there, but I'm selectively passing that, okay, these three arguments should be passed. So these are the variable arguments. If I want to accept all of these and prepare a query out of it, in that case, let's do it. That function would take a different form. Instead of single star, we would be accepting double stars. Okay, let's see what happens when it comes to single star. It says got an unexpected keyword argument name, but it was expecting a positional argument here. Okay, so that gave us a problem. So instead of positional parameters, when you pass the keyword parameters, you need to change single star to double star. That should work, but now it says that res is actually of int type, so I'll convert that into this. First thing that you have received is city name country, but you want the other part, right? We'll evaluate what args is first and then try to loop over it. So I say print args. Okay, so that's a dictionary this time. Dictionary's keys would be holding the name of the parameters that you have passed. Dictionary's values would be holding the values of the parameters that you have passed. Of course, there always is going to be one is to one relationship, and it is not going to be messed up. The order can be a bit weird. Okay, the order in which you are passing the details may not be the same order. So if I'm getting a dictionary, we already know how to loop over a dictionary, right? And these kind of arguments are called keyword arguments. KWARGS. So I would call it keyword arguments. How to use it? I told you that I would be creating a query. So let's say we loop over it for every key and value in kwargs dot items. Okay, so you'll be creating a query. The query should be something like this: insert into database, and whatever the column names are. So insert into some table name. So the query would be like this. The initial part of the query equals to insert into some table called users. Then there should be some column, right? The name of the column should be there, and after that there should be a keyword called values, and then some values, right? So that's the syntax. So let's take this query, prepare it here at the end of the for loop. And what do I need? I need variable users, user columns. So I would say %s again, and values would be %s again. We would be creating the keys and values from this. Why do we need to loop over key and value at the same time? Because we need to guarantee the one is to one relationship. If I take the keys different and values different, we know that dictionary doesn't play with the order. You would be mismatching the order. So that's why I need to loop over both of these at once. I would say my calls or columns, let's make it empty string. Then the values equals to empty string. We say columns plus equals to the key, and my values plus equals to value. But before that, we also need to add a comma, right? Comma should be present. Similarly with the key. So we are trying to just move one step at a time. This percentage should be taking two different parameters. So I would add it by using mod columns comma values. That's my final query, and I'm going to return that query back. Okay. There would not be the exact query generated currently because there is going to be a problem with the comma. Let me show you what it's going to be. Not enough arguments for format string. Okay. So now it says insert into users city name country values alpha abc and gamma. The order is maintained, but what about the initial comma? How do I get rid of it? One way to get rid of it is to simply remove the first element. Other nice way is to instead of converting that into a string at this calls plus equals to and values plus equals to, I'm converting that into an appended string. What you could do is you could simply add it to a list, and at the last you could merge the list down or join the list. So in that case also you wouldn't be not getting the comma again. So it would be easy way to do. Let me show you. There is another way of achieving this that we have just achieved. Calls dot append, and I would be appending the key, and values dot append would be value. So your calls and values are going to be empty lists. I would say here instead of this, let's give a call to join method and pass this comma dot values, sorry, not values, join, pass values to it. Okay, so that should take care of it. Again, no commas in between, sorry, no commas at the start or at the end. So this has taken care of the comma part for us. There are multiple ways to do things. We have seen how to pass um, positional arguments, multiple positional arguments, and we have also seen how to pass multiple keyword arguments. That we don't know how many arguments are coming in, we should be able to generate a query out of it. Okay, so that's all about the functional part here. We have also seen an example of dynamic programming yesterday, where we have used some external variables inside the function. So let's talk a little bit about what the variable scope is, and then we'll be jumping to the next section here, which is classes, modules, and packages. So, okay, we are talking about the variable scope. I have a variable called var holding value 1. Then I have a function which would say modify. I'm trying to do var equals to 2. Then at end I would print var. Then I would print modify, or simply give a call to modify. Modify can take care of printing the variable, and we print var again. Okay, so here the var equals to 2, which is written inside the function, the scope of it is limited to the function itself. So the answer that you would be getting, can anyone help me with the answer? What answer you would be getting here? You would be getting 3 print statements, one from within the modify and 2 print statements here. So I just need the order of it. What is going to be the answer? Can anyone help me with that? Okay, so let's see. Here the answer is going to be print var, which is 1. Then we haven't given a call. Okay, so I gave a call now. And 2, which is inside the function, gave us a value 2. The external variable was still not changed. The external variable would change only if we write a global statement inside the function. Now the function knows that the variable that I'm going to use internally should be used from the external scope. Okay, now this is when you would be getting the answer as 1 2 2 and not 1 to 1. Currently you are getting answer 1 to 1. Now after the changes you would be getting the answer as 1 to 2 because the change happens to be in the global section now, not in the local. Okay, so any of the stuff that you use inside a function is local to the function. Talking of the references, let's say I have an object called L which is of type list, and the list is holding values 1 and 2. Again the modify function comes in. What I want to do is I want to append 3 to the list. Okay, then I print the list. Very simple. So I would be printing L first, then I will give a call to modify, would pass the list to it. Okay, and then would try to print L again. Now in this case, what is going to be the answer? The initial print L, which is on the line number 7, would give you 1 and 2 for sure, because there is nothing which is changing here. What about the modify L? It would also print the L, the list. Is it going to be 1 2 or is it going to be 1 2 3? Okay, so let me run this. I'll explain it to you. So the initial 1 2 is coming from line number 7. Since the list is in its default state 1 2, it would be printing 1 2 there. What about the print L, which is inside the function? For sure it would give us 1 2 3, but we haven't expected print L, which is outside the function, to print 1 2 3 even, because we have seen in the last example that if I want to modify the variables in the global state, in that case I need to use the global keyword, but now I haven't used the global keyword, but still I'm able to get the effects of that modification inside the function to be outside of it. Such functions are called modifiers, and that happens because all the variables are passed by value, all the objects are passed by reference by default. As soon as you assign the reference to some another variable, that reference is lost, and now you'll be getting 1 2, then 1 2 3, and again uh, sorry, let me do this again. L dot append equals to M. It has to be like this, sorry for that. Okay, as soon as you assign the references to something else, the references are lost. The variable is the same variable L that we have used earlier. The only thing that I've changed here is that I've assigned it a value now, The value is 1 comma 2 again. It's not a different value altogether. But when you try to execute the program again, the println, which is on line number 10, would give you 1 2 and one, not 1 2 3. The reason is, as soon as you assign the value to the reference that you are holding, the reference is changed. Okay, and when the reference is changed, in this case the reference is local to the function. The new reference that you are talking of, it is local to the function. The earlier reference that you passed on line number 9 was external. So references do not know whether they are external or internal. It is the responsibility of the programmer to figure it out. Okay, so we'll see such examples come in the coming section. Let's jump to the newer part, which is classes. When you have a lot of functions and you want to bundle it up into one single group, the name of that group is class at the very basic level. When you talk of the exact definition of a class, so people would like to say that it is a blueprint for creating objects. Here in Python, we use the keyword as instance instead of an object. Okay. So when we talk of classes, they are defined like this. Class is a keyword, space, um, and then we can write the class name. Now that's the nomenclature um, in the class. Sorry, in the class name, we write the name always as caps first and then the small characters. If there are multiple words in there, in that case, you would be writing it like this: A, B, C, M, N, O, X, Y, Z, and so on. Okay, for now, ABC is my class name. Class name, after class name, we have a colon that marks beginning of the class. Now, inside the class, there are two different kinds of variables. One of the class of variables is called class variables. Another one is called instance variables. There's no big difference between that, but it defines the way we use it. So if I type in something like this, x equals to 0, that's an attribute. Okay, and whenever you create an object of that class, x would be present in all the instances. Okay, so such variables are called actually the class variables because they are defined in class and they would be present with all the instances. They would be shared. When you write something like this in the constructor, let me write a constructor. Def constructor starts with underscores, two underscores actually, init keyword and two underscores again, parenthesis, normal function definition. Okay, and if you want to pass some parameters to it, you could pass the parameters. If you set up the variables like this, self.y equals to 0, in that case, your self.y or simply y variable is an instance variable. That is very specific to the instance and the values are going to be not shared between the two instances which are there. If you don't want to specify anything or don't want to define anything in a class, that is also doable. So like we see that we need a colon to start the block. Okay, but if I don't want to write anything, how do I get rid of this problem? I would simply add a keyword called pass. Pass means add nothing here. It's an null block. How do I create an object of ABC? I would say A equals to, write a class name, call it using a parenthesis, and that's how you create an instance of a class. So A is an instance of class ABC. Class ABC does not hold any attributes. It does not have any methods inside of it, but still it's an empty class. So we have got an empty instance. In Python, there is one interesting thing that if you have an empty instance or maybe any instance for that say, you could set up the variables all by yourself. So I could say a.x equals to 6 and a.y equals to 3. In that case, x and y would be the variables that are present on the instance called a, and that is perfectly fine. A is still an instance. Okay, so if you see, it says main.abc, the instance is at so and so address. Why main.abc? Because class abc is defined in a class which abc is a class that is defined in the main file, the file that marks the start of the program. So here print a.x would work, print a.y would work just fine. But these variables are local or very specific to the instance, hence called as instance variables as well. What about the methods? How to write the methods? So let's write a method. I want a class that should be able to do some mathematical operations on two different numbers. Okay, so I would call this class as class math, and I need some methods inside of it. So I would create a method. The difference between a general function and a method in a class is that methods in a class would be passed one argument by default in the beginning. That argument is the reference to the instance itself. Let me show you what I'm trying to say here. Def add, it accepts two parameters, right? So if I'm creating an object, I do not need to pass the two arguments to all of these functions. So what I would be doing instead is, in the constructor itself, I would set up the values. I need two values x and y. Okay, so I would set it up inside the function. So I would say self.x equals to x and self.y equals to y. All right, and add, when I give a call, I would simply return the value. The value would be self.x plus self.y. Self has exactly the same use as the this keyword in Java. Java script, not exactly Java, or even in Java you could call it. So it references or has the usage just like the this keyword in other languages. Okay, so how would this work? Um, I want to show you the parameter list which is taken in by the init keyword. So here, when you create object or instance of the class math, I will be creating an object. So it says object ob equals to math. Give a call, and it is expecting two parameters, right? So I need to pass two parameters, that's for sure. But let's run the program and see what happens. It says init is actually taking two arguments. Okay, I know that it is taking two arguments, but one is given. Are we passing any argument here? No, we are not. So it still says that one argument is provided to it. So the arguments are provided by default. The first argument is always provided by default, and the argument would be a reference to itself. The self keyword that I'm using is also passed as an argument. It is not available to be used directly inside the class. Okay, that's what is different in Python and in other other object-oriented programming languages. So you need to take in the self parameter as the very first parameter in any of the function, like this. Okay, you could also define static functions if you want to. So static function, let's calculate square root or simply exponential. So I would say exponential of number n. In this case, I'm not supposed to be accepting self, and I would return n raised to n. Simple. Calculate square of it, not exponential. Make sense? Okay. So here, the static functions would be accepting a decorator method, static method. Okay. So these are static methods that you need to specify externally that this method is a static method. So do not pass the self argument to it by default. And how do I call the static method? You could directly call a static method without creating the instance. You could say math.exp or sqr and pass some value to it. It should be expecting some value out. Okay, removing the line, that is. So that would work without passing the parameter, without passing the self reference to it. You'll have to define it like this, a static method. But what about add? If I want to call add, what do I need to do? So let's check. Very first, we are giving a call to the class to create an object. The class requires two arguments to be passed. Now in this case, if you execute this, it would say that init takes three arguments, but one is given. So if one is already given, I need to worry about only two arguments more. I would say 5 comma 7. So it has taken 5 and 7, stored it in x and y. If you give a call to like that x like this, ob.x, and print ob.y, they should be able to get you the answers. So the answers are 5 and 7 for x and y. Okay, what about add? Give a call to the method like this, ob.add, and now we don't need to pass any of the parameters. It is expecting one parameter, but it is going to be passed automatically to it. What is the answer of ob add? Let's print it out. It's very simple. If it is 5 and 7, it would be generating 12. Okay, so now you know about the different methods, but there are also magic methods inside the instances, and these magic methods are defined by default. If you want to override them, you are free to override them. One of such matching methods is the constructor itself. If you want to define it, you define it. If you want to override it. Otherwise, it would be called by default. None of the arguments would be passed to it. Okay, so it's all up to you how to play with that. Another method is this. If I simply try to print my object, it would not give me a senseful output. It would say that it is a math instance at some address, but from the layman's term, I wouldn't be able to understand what is it exactly. So what we could do is we could simply write another method inside the class, which is underscore underscore str double underscores again, which would be taking the self parameter, and then we return a string. So I would be returning that I am adding, or I am simply I contain x colon %d and y colon %d. Anything, you could return anything out of it. Just it should represent that particular object. Self.x, self.y. Okay. So now if I print ob.add, it would give me a nice result. So that is understandable, right? Instead of checking what the address is, you could override that str method to generate some sensible output. So this could be used in some different kind of things. Let me show you some another methods that we could override. Operator overloading. If I want to add um, 2 points, okay. So let's say we have uh, a complex number. Rather, Python actually supports working on complex numbers by default. So I could say something like this: x equals to a complex number 5 plus 6j. We use I, right? In general usage we use I, but here in Python we could use it using the j part. J part is the imaginary part here, and y equals to 9 plus 3j. We could perform some operations on it. Print x plus y, okay, or print x minus y. Now this is the answer, 14 plus 9j minus 4 plus 3j and so on. So we could work on complex numbers directly. That's easy. But if I want to implement that using my own class, so what I would be doing is, let's say I have a class, the same operation that we did, we are going to do it using the class part. So I have a class called complex. Now this class takes in two parameters. So I would say def give me a constructor that accepts two parameters. First parameter is by default, it's self. Next two parameters, one is uh, the real part, another one is the imaginary part. Okay, so self dot real equals to real and self dot imaginary equals to imaginary. So I've set up the values. I want to print a nice representation of it. So I would say str self and return what? Return a representation like this, which would the same representation that we are looking at, 14 plus 9j, right? So I need the similar representation. So I would say %d comma %d j, right? And we would be using a tuple that has self dot real comma self dot img. Okay, so far so good. We have a number. So I will be creating a number x, which is actually a complex number, and holding some value 5 comma 6. So 5 plus 6 j is what is it's going to be, and y holds another value. So it might be having a value 3 comma 2. Okay, so let's print them out and see what they look like. Print x, print y. 5 comma 6j, 3 comma 2j. But if you want plus and minus signs, we could also override that. So I could say something like this: %s in between, and that %s would be chosen based on whether the number is plus or minus. So I would check type plus if, now check the syntax here which I'm tapping between the two commas. It is a one-liner if-else statement. Give me plus if self.img is greater than or equals to 0, else give me minus. Make sense? So it is 5 plus 6j. If I pass it a minus sign, I would be getting a minus sign. What about the double minus sign? Just get rid of it. We don't need minus sign in this case. There you go. Now it looks nice. Okay, so that is about the string format. But if we want to add two numbers, since both of these x and y are now not complex numbers, actually they are the objects that we have defined, we need to make sure that we are able to do plus and minus operations on it. So for that to happen, we need to override some more magic methods. So the method is going to be underscore underscore double a double d and double underscores again, expecting the self parameter and the object. So I would return a complex number again. Okay, and I would return a complex number that would be, the real part is going to be self dot x, self dot real, it's adding, right? So self dot real plus obj dot real, the object that we are passing. self plus the object. Now how it is getting called? It would be getting called by default when you use the plus operator between these two objects. So let me show it to you. Another one is self dot imaginary part plus object dot imaginary part. All right, so let's check it. Z equals to x plus y. So I could now add the two objects like this and then print z, and there's the answer, 8 plus 4j. 5 plus 3 is 8, 6 minus 2 is 4. That's how the answer is. And we are able to use the plus operator because of this magic method. There are multiple magic methods as well. Instead of add, you could have SUB, you could have MUL, multiply, you could have DIV as division, you could have EXP as exponential, you could have REM as remainder, you could have CMP as compare. So every operator is able to be overloaded using these magic methods. Okay, you would be expecting two parameters. One is the self, that means the instance itself, and the obj, which is on the right hand side. So the call is made to the x instance and y is passed to it. That's what is happening in the background. So I could create some more methods for subtracting, multiplying, dividing these complex numbers and provide my own logic there, whatever I want to provide. So currently I'm returning the complex object itself, but with two different values. So what is the value of z dot x? It would give me the real part. Okay, there is no value. Uh, it's real, right? Okay. Z dot real is the real part. Z dot imaginary would be the imaginary part. But if you think that I should not be able to use real and imaginary directly from outside the function, since one of the properties of object-oriented program is called encapsulation and abstraction, right? So for doing that, there are some naming parameters that you need to follow. The naming parameters are, if you do not have any underscores before the name, in that case it is public. There are no access specifiers in Python. There is nothing like public, private, protected. So if you are placing no underscores, that means it's public. If you are placing one underscore, then that is protected. If you are placing two underscores, it's private. Okay, so the methods that you see here, two underscores init, two underscores str, two underscores add, you cannot give them a call directly using the object. So these are private methods. Remember that if you are defining your own private method, you don't have to have two underscores at the end of it. If you add two underscores at the end of it, that is supposed to be system internal. Okay, so don't do that. So how do I convert this real and imaginary into the protected variables? So I would simply add underscores before them. Okay, so wherever there is real, let me convert that. So I'm trying to find this out and then find all, add underscore to it. What about img? Find all img and write underscores to it. Okay, I don't need underscores in the parameters though. Okay, so that is all set. Let's try to access those things again. Program works, no problem with that. Print z dot underscore real. Okay, that worked because that was let me check this. Now this shouldn't cause a problem. Yeah, so it says it has no attribute real. If you don't call it, you should still be able to run the program. So if I don't call this line, the program works just fine, but the double underscore real is not accessible from outside the world. Okay, so that's the private variable which is not available outside. Why we were able to access the protected? Because protected can be inherited into its subclasses, so that is accessible outside, but just at one single level. So if you call that directly on an object, you should be able to call it. So that's how you specify whether it is going to be a private method or a private attribute. Not just attributes, you could also write your method names accordingly. So if I have a method called alpha and that has got two underscores before it, in that case I will not be able to call this method from outside the class. Okay, so that would create a problem. So let's give it a shot. Self, I say print alpha. Okay, let's try and give it a shot here. Print, or just give a call to z dot alpha. So it says complex instance has no attribute underscore underscore alpha. That is not callable. But what if I remove the underscore? Now that works. Okay, so now you know how to play with these access things like private, public, and protected. By default, everything is set up to be public because you are not adding any underscores there. Let's take an example which would be in which we would be talking about the inheritance part of Python. So there are multiple inheritance types that are supported by Python. Simple inheritance, where class B would be having all the parameters of class A. It would be inheriting all the methods and all the parameters as well as attributes from A. Another one is multi-level, where it goes like this. C inherits from B and B inherits in turn from A. So that's multi-level. That's another one. There's another one called multiple inheritance, which was initially found in the C++ language. Java got rid of it. They implemented that using a false interface. But here in Python, we can have truly two classes inheriting into one. So it's something like this. We have class A, we have class B, and class A and B inherits into a common class called class C. Okay, if that's happening, C would be holding the attributes as well as the methods from both the classes. So there arises a question. We are already aware of what simple and multi-level is going to be. That happens in the happens in the incremental fashion, right? So if A is having one method and B is having another method, C would be having both the methods. That's simple addition. But what in case of multiple inheritance? If my A class is exactly same as B, having maybe four methods, and B is just a little bit different, so B is having one fifth method into it. So four methods from B are a part of A itself, and there is a fifth method in B which is different. So how many methods do you think C would be inheriting? In the case of multiple inheritance, we have precedence order. All the precedences on the left hand side are given more priorities. So let me show you what I'm talking of. I need a class pet. Okay, for defining this, I need a class pet. But before jumping to that, I would say let's take a small break because that is going to be a lot of concepts that we have covered in a day. I would be taking a short break first, then we'll be coming back in next 5 minutes and we'll talk about inheritance in detail. Okay, so here it's 9:06 on my clock and I will be back exactly in 5 minutes, which is going to be 9:11. So here we have seen how to create a module, right? So modules were created from the files. We have moved the class to the files and placed the files into a folder. So we call those folders as packages. What is the use of init.pp? Init.pp actually can have all the default parameters for that particular package. So if I say in init.pp, let's edit that file. I would say name equals to the name of the package is animal, and how do I use it? Inside my example.py, I would say import animals. Okay, then try to print animals dot name. Now it says animal. So any of the package specific attributes you could present inside init.pp, sorry, init.py, but it's not mandatory to be there. So this would be the generic structure of package. Folder, inside of the folder there would be files. Inside the files you could be placing multiple classes. Generally the structure is one class per file. Okay, and your file name should be all in small and your class name should be the first character caps. So that's about the default thing here in Python for the OOPS related programming or object oriented programming concepts in Python. So far what we have seen is if-else structure. Then we have seen the loops, we have seen the variables, we know that there are no constants, we know there are no case statements. We have seen multiple ways to use a function. We have seen examples of recursion, dynamic programming, functions as modifiers, functions as simple functions, functions as fruitful functions. We have seen how to use the iterables like strings, tuples, lists, dictionaries. Okay, we have seen how to write classes. We have seen simple inheritance. We have seen multiple inheritance. We have seen how to move the class to a file and call it a module, then move a file inside a folder and call it a package. So what's coming up next is we are going to look into sets tomorrow. Okay, and the next thing that we will be covering is a scripting language called bash. Okay, so if you want to bring in any questions or doubts related to Python, make sure you do it tomorrow itself, otherwise it would be a big gap with the topic. So I would, if you bring in the questions, I would rather love to dedicate tomorrow's class as well to the Python part. Okay, otherwise you would be moving to sets, see a few usage of sets, then we would be looking at a few more modules which are available in Python, the default modules. Like there is a OS module, then there is a sys module that would help us in taking the arguments from the command line parameters to the script directly. We would learn about how to work with files, how to write to a file, how to read from a file, and all those kind of things in tomorrow's class. And if time permits, we'll be starting with bash. So that's all from my side for today. Any queries or doubts are welcome. Anyone would like to ask any questions? Just make sure that you understand everything. Okay, and just in case if you don't, feel free to ask the questions at any time. Okay, so I guess there are no questions though. So we'll be getting up the call for today. We'll meet again at the same time in tomorrow's class, which is going to be 8 a.m. IST. Okay, and would move with the other topics which are there with the Python. So we have covered the basic part, all the structures of Python, but we are yet not finished with the modules which are predefined in Python and a few useful ones that we would be looking into tomorrow. So thank you so much for attending the class today and have a great day ahead.